form of x plus iy, right? A real part and the imaginary part, and it will be defined for some z, okay, on a continuous curve c. Okay, let's say so maybe it's an integral, where you're giving the upper limit and the lower limit. Okay, it can be a closed integral as well. And if this is the function fz is dz, we can actually write it down as u plus iv. If you remember, fz we've seen already. Okay, fz is equal to u plus iv. Okay, and z is x plus iy, so dz can be written as dx plus idy. Okay, so that's the integration form that you're going to have, and based on this idea we can actually solve some problems. So let's see. So let's say I take this example. We have to find out the value of this particular integral, and the limits here are given to be 1 plus I and 0, right? So there is a catch here, and I think this is something that's not very difficult. You can always write down these limits in the form of x plus iy, and depending on whatever values are given, you can actually write down what is the value of x. So if this is 0, that means x must be 0, and y must be 0. So that's the range, right? X is 0, y is 0, and here also it's just x plus iy. You can just compare it and see what is the value of x and y, so that you know the limit for x and y, right? So x is 1 here, this value, right? X is 1, and y is also 1, because it's I y, right? So it is 1. So you know the limits now. And the problem here is this is a mix. This is a mix of x and y, and dz also you can write it down as dx plus I dy. Okay, so that means you have to write it down in terms of one variable, and you have to find out the value of this integral along y is equal to x and along y is equal to x square. So this is basically a parabolic form, you can say, right? So in general, I'll just explain this. You really don't need to draw the diagram every time you do it. um, you can actually have a graph, okay, something like this. And if you want to draw find out the value of the limit along y is equal to x, that means you're going to find it out along this straight line, right? So this straight line, okay, that we have will actually represent your y is equal to x. Okay, and if we talk about y is equal to x square, that means we are talking about a parabola. Of course it will have a negative part and a positive part. Okay, we just draw one part, I think it's okay. So this is y is equal to x square, right? So if you look into this, you can check what are the limit values. Okay, x goes from 0 to 1, y goes from 0 to 1, right? So maybe this point is 0 0, right? And this point is 1 1. And dz can be written as dx plus I dy. So I can write it down as dx plus I. In place of dy, I can write down dx, because dy is dx, right? So everything is in terms of x. That means the limit will be for x 0 to 1. So I just do it from 0 to 1. Okay, and then you can do your integration, and you can actually find out the answer, right? So this is basically nothing but this is the line integral that we have. Okay, so that's very important. Okay, so you can just put the limits and everything, and then maybe we can just expand this. So 0 to 1. Okay, x square plus ix 1 plus I dx, right? I have 1 plus I outside, and inside dx x square. So we can just have it as x cubed by 3 plus ix dx. So it is I x square divided by 2, and limit is 0 to 1, right? So 0, you don't need to worry, everything is 0. Upper limit you just put 1, so it is 1 plus I. Okay, and then you can actually calculate it easily, right? So this will be what, 2 plus 3 I guess. Okay, just take this x cubed by 3, so it will be 1 by 3 plus I by 2. Correct. So you take the LCM and everything, and when you do it finally, you are going to get it as minus 1 plus 5i divided by 6. So you can do it in shortcut also, but anyway, let me just do it so that all of us are on the same page. So I'll just take this first x square plus uh, ix square. This is with 1, so I'll just keep it simple. And then x square with 2ix is minus, okay, 2ix, so it will be plus 2ix cubed. And then this with this ix with this ix, so it's minus, so it is 2x cubed dx. So 0 to 1, I can take x square common, this will be 1 plus I. Here I can take plus 2x cubed common, okay, this will be 1 minus I dx. And then of course you can integrate it, okay. So 1 plus I x cubed by 3 plus 2I x to the power 4 by 4, 0 to 1, right? So you should be able to get it right. So this 2, this get cancelled here. So 1 plus I, 1 by 3 plus I into 1, right? Divided by 2. To get this. To do it, you should get minus 1 plus 5I divided by 6. That should be the answer, okay? Please do it, okay? If you do it and you get the answer, you get that confidence. If I keep on doing it, it becomes a bit confusing. Anyway. Let's do one more, okay? Let me give you one more sum now. This is something which I'm expecting and everyone should answer me because I've already told you the procedure. So you should be able to give me a correct answer. Evaluate. Integration. 1 minus I to 2 plus I. Okay. And this is 2x plus IY plus 1 z. And give you the path along which you have to do your calculations along. X is equal to t plus 1 and y is equal to 2t square minus 1. Okay, not n, sorry, just wait. I will just correct this. These are actually defined for the same path, same x and y. Okay, this is 2 square and number 2 straight line. Okay. Okay. So you can try doing this. Okay, maybe okay, I'm going to write on this side. So try doing this. Okay, it's also very simple. You have to use the same technique. You have to replace the term t in terms of that equation, right? Yeah. And I hope straight line. If I say, you can also write it in this way: 1 minus I and 2 plus I. Okay, that's the straight line we're talking about. So here you can see what are the limits of x and y. Okay, and then you can write it down x and y in terms of t, and then you can do it accordingly. Replace it and do it. Okay, try doing this in terms of t. So that means the limit that you're going to add should be in terms of t. Okay, so just do this, and this would be nothing but 2t square minus 1. So this dy would be 2t t t, right? So we know everything is going to be in terms of t. Now here, if we just talk about x, you can either consider x or y, does not matter. Okay, here what is my x, 2, what is my y, 1. Here what is my x, 1, what is my y minus 1, right? So when you put the limit, so maybe I want to change from the x system to the t system, so I can put x is equal to 1, and when
Sir,
this happens, yeah,
sir, I got second one. That is 4 plus 8i.
second one you got it to be 4 plus 8i. Okay, we'll check that.
Yes.
Let's just finish the first one. X is equal to t plus 1, so x value I'll put 1, so it will be 1 minus 1, so t is equal to 0. So that's how you put the limit. And if you put x is equal to 2 here, okay, this is 2, I'll put x is equal to 2, implies 2 is equal to t plus 1, so t is equal to 1, right? So that means the limit would be basically from 0 to 1. Now we can actually do it. We can just put the value of this is 0 and this as 1, okay, and this is 2x, so this is 2 times of x is nothing but t plus 1, so I'll put t plus 1 plus I y is 2t square minus 1, and then we have got plus 1, and then dz. What is my dz? Dz is dx, dx is dt plus I dy, so I dy is 2t dt. So you see everything comes in terms of t now. Limits also we have changed it in terms of t, and now we can easily solve it. Obvious question might come in mind that I have written the value of x and found out the value of t. If I write down the value of y, will I get the same value of t? The answer is yes, because you can take this function now, okay, and accordingly put the value of y and then see what is the value of t. You're going to get a similar limit, okay, and that's it, right? And just do it. So dt dt takes out, so it is t dt, right? So you can just expand this and do it, okay? Anyway, I don't think I need to do it. It's very simple, okay? Let me write down the final answer. I think all of you got it, okay? So just expand it and do it, and when you do, you should get the answer to be 4 plus 25 divided by 3. Okay, so whatever answer you got is correct. The three of you got this and this. So you have to just put the limit, and then it's just simple integration. Just do it accordingly, and that's easy. What you can do is you can, here you can actually separate out the real part and the imaginary part and do the integration and make the things much more simpler. Okay. Let's just have a look at the second problem. Okay. The second problem is kind of a bit different, and here you need to know a bit of geometry, okay, and one of your friends has already answered. The answer is 4 plus 8i, and actually that's correct, okay, that's the answer, 4 plus 8i. Okay, I'll just give you one hint here how to do it. So when we look into this straight line 1 minus 1, 1 minus I and 2 plus I, you know the coordinate x1 x2 y1 y2, you already know the coordinates here, okay. So I can actually write down the equation of a straight line now from here. So okay, this is a way to do it. Coordinates, what are my coordinates here? This is 1 minus 1, because this is 1 minus I, so x plus iy, and this is 2 plus I, so 2 is the x coordinate, and plus iy, so 1 is the y coordinate. Okay, I will just still explain this. X plus iy, this is 2 plus I, so compare and you get the coordinate of x and y. Okay, so it's a straight line, so just find out the equation of straight line, right? It's a straight line equation, so we can write down the straight line equation, and if you remember, this is y minus y1. So you need to have a lot of prior knowledge. These kind of problems and these formulas would be taught, and if I'm giving you a question in exam also, it is expected that you actually know some of them. I won't try to deviate too much from whatever I've taught, okay, so don't be so scared. X2 minus x1, right? And you can actually put the values and everything, okay, and then you can actually get the result here, okay. And this particular result, or maybe I can just write it down. Let's say, simplify this for you, make it easy. To write it down in terms of t, and this is the equation of a straight line, so I can just put it to be, let's say, t, right? And then what you can do is you can equate each of them individually, okay. So you can just, maybe you can write it down as y minus y1, What is my y1? It is 2. Okay. Uh, Sorry, not 2. Where is my okay? I think I've written wrong. Okay, no, this is 1. Fine. Okay.
So my
So
y1 minus.
what? Yeah, y1 is -1. Right? This is -1. So this is my y1, and this is my y2. Okay. So y minus y1. So that means it is -1. So it will be +1 divided by y2 minus y1. Y2 is 1. Okay. And then +1. I can take is equal to t, and then this is y plus 1, this is 2t, so y is equal to 2t minus 1. So we got y in terms of t, and similarly we can do it x minus x1. So x1 is 1 divided by x2 minus x1. So 2 minus 1, 2 minus 1 is equal to t. So in that way I can say that x is equal to कितना हुआ ये 1 चला गया x t plus 1, right? T plus 1. That's it. So you are going to get a similar thing, right? So you see, you're going to get it now, and then you can simply put the values, whatever we have done before, use a similar step. Okay, I'm going to get this answer is 4 plus 8i. So this particular question, the second part, you have to just find out what is the form of y in terms of t, and what is the form of x in terms of t, and then you can actually put the values and find out what are the limits for t, just like this. Once you get this form, it is like standard integration, which you have been doing for ages. Okay, so the answer for this is uh, 4 plus 8i, correct, and the answer for this is 4 plus 25 by 3. Okay. So it's a very simple thing, complex integration, and that's why I did not put too many problems here. This is a kind of practice, because complex integration you might have already done before. So it's a kind of revision that we should actually do. Okay. Now why I'm doing this, because there is a topic of pole and residue which you have to do, and there actually you have to use the integral theorem and all, and these kind of integration you will come across these kind of problems. You may come across these kind of problems. Okay. So what we're going to do with the next topic is actually Cauchy integral theorem. So I know the time is up, but then I'm just going to give an introduction to this, and then probably take up a sum in the next class for this. So Cauchy integral theorem. Okay. And what does it say? That it's actually we're doing a complex analysis, so we are always talking about complex functions here. So what we have here is, if a complex function, okay, fz, let's say, is always analytic, okay, or maybe I can just remove this word, always. If a complex function is, let's say, analytic, okay, on a simple closed curve, we're going to take an example and we're going to understand it better. Simple closed curve, let's say C. Then if you take the integration of that, fz tz, this will be 0. Okay, so in that closed curve the integration is basically going to be 0. Okay, so C. Okay, and based on this we actually have, this is the theorem, and based on this we actually have the Cauchy formula integral formula. Okay, let me just give you this also. If fz, we're going to take up an example and going to prove it. Cauchy integral formula also we probably will prove it eventually, but then first of all we are going to understand its use, and then probably we are going to do it. If fz is an analytic function in a closed curve C, okay, and A is any point, okay, this A is actually any point within C, any point within C, then what we have is f of A. Okay, we can directly replace the variable with A. is equal to 1 divided by 2 pi I integration of fz divided by z minus a. So this definitely has a proof. This is the result, and this definitely has a proof of Cauchy integral formula. We're going to do it eventually, but right now what we're going to do is we are going to just use this formula to derive some answers. Okay, so you can directly write down the integration in this way, and then you can solve it, and you will see that the answers that you derive it comes out in a very simple way. Okay, so that's very important. So it can be it's a function which is there, and then you can take an f dash of the first order differentiation, second order differentiation, and so on. Okay, so maybe I can just give you some more points here. If we differentiate, we are going to use it in the next class. Okay, if we differentiate, okay, you can differentiate partially on both sides. This can be written as fz divided by z minus a whole square, differentiating with respect to a. Okay, maybe I should write it down here, otherwise we're confused. With respect to a, not z. With respect to a, if we just differentiate it, z minus a whole square, this is the z. Okay, and this will be equal to, I can just cross multiply 2 pi a, 2 pi I, take it there, and this will be f dash of a. Okay. And what we can do is we can actually keep on differentiating this a number of times. Again, we can take it fz divided by, again differentiate with respect to a, z minus a whole cubed, dz is equal to 2 pi I divided by 2, right? Because it was 2 there. Okay, so when you differentiate it, you get that value, and then it will be 2 into fz divided by z minus a whole cube dz. So 2 pi I divided by 2 f double dash a. Okay, I hope you understand this. It's not difficult. dA of fz is there. It's a constant. 1 divided by z minus a. Right? We're doing this. So nx to the power n minus 1. So minus 1 to the power z minus a to the power minus 2. Right? Into dA of z minus a, which is again minus 1. Right? So it will be 1 divided by z minus a. So this is something basic which you have already done. So you should not make confused here. So z minus a square, 1 divided by z minus a square. That is why it is 1 divided by z minus a square. That's it. So if you do it again, differentiate it again, you get this term. And then this way you can actually differentiate it n times. And if you differentiate it n times, you can actually get it to be fz. So I differentiated it the first time. This was actually 2. I differentiated it at first time. It was 2. That means it is first plus 1. Differentiated it for the second time. It was 3. Right. So in a similar way, if I use this, this will be z minus a. Differentiate it for the nth time. This will be n plus 1. Right. Dz, of course, is equal to 2 pi I. First time denominator was 1. Second time denominator was 2. Nth time denominator will be factorial n. Okay, if you keep on doing, you'll see this 1, 2, then it'll be 3 into 2, and so on. 4 into 3 into 2, and so on. So keep on doing it, and you can get that answer. Okay, and this will be f and a, n times differentiation. Okay, so I'm just doing it because we need the results, and that's why I'm just doing it and keeping it ready. Okay, you will eventually need it somewhere. Okay, and one more thing, this is basically a note. This is also something which is expected that you already know. Okay, the note is, if I actually write down, let's say, modulus of z is equal to r, you can straight away know what is the center. This is 0, 0. Okay, and the radius is r. Okay, you know the center, you know the radius, okay, or the distance from the center, and then if I write down z minus a is equal to r, we know the center is a0. All these results we are going to use. Radius is r, of course. maybe z minus bi if I write down is equal to r. The coordinate is bi, so that means we're talking about the y coordinate. So it is 0, b, and radius will remain as r. One more form might be, z minus a plus ib is equal to r. The center is ab, of course, right? This and this. So you whether we do it in class or not, you will come across this. Okay, this is something which you will need again and again. So these two things you should remember. Okay, maybe you can take a screenshot of it and write it down later if you have not already written it. But I'd suggest that you try to remember this. This is Cauchy's integral theorem. This is Cauchy's integral formula, which we are going to prove later. In the next class, we are going to take up examples where we actually use Cauchy's integral formula, and we see even the complex integrations will become simpler. Okay, using this particular formula. So once we know how to use it, we can put it into good use, and then you can do numericals faster and so on. Okay, so it's a two-way thing. We also do it for your exam purpose, but at the same time, these kind of questions or use of Cauchy integral formula is very common even in entrance exams also.